late. Okay, but moving forward, we'll see this. Okay, so our general formula, okay, is this A is equal to P, okay, open parentheses, 1 plus or minus, okay, R over N, close parentheses, raised to the N times T. Okay, so A represents your total amount, okay, P represents your principal, R represents the rate, okay, N represents the number of times it happens in a year, okay, so that's an important piece to what's new, okay, we didn't have N yesterday, okay, N represents the number of times this would be compounded in a year, okay, and then T represents the time in years, okay. Yesterday we had this, we called this initial amount, okay, initial amount is the same thing as principal, okay, so those two words can be used either way. All right, but what we want to figure out is the total amount, okay, if a coin had a value of $1.17 in 1995, okay, its value has been increasing at 9% per year, okay, what is the value after 5 years? All right, so looking at this problem, all right, what was my initial amount, okay, what was this coin worth?
$1.17.
Okay, it was worth $1.17, so $1.17. Okay, we want to figure out at the end, what is the total amount now? We'll call that A.
9.0.
All right, so with this, we want to multiply. Okay, we've got 1 plus, because we're increasing the value, right? And we've got 9%. 9% is what is the decimal?
0.09.
0.09. Okay, and that needs to go over N. Okay, N is the number of times it's compounded in a year, how many times it would increase value in a year. Okay, how many times does this increase value in a year?
5.
Okay, be careful, because 5 is the amount of years that we're looking at right at the end. How much is the value worth after 5 years? Okay, but this is only increasing how many times a year? If we've got per year, okay, that's just going to be 1 time a year. Okay, it's only going to increase in value 1 time a year. Okay, but we're looking at the end, what is the value after 5 years? So as far as the times it's increasing in a year, that value would be 1. Okay. So that was our N value, right? This was our N value. N's also in our exponent up here. Okay, so we need to put 1 in our exponent. We're going to put that in parentheses. Okay, then we've got T, the amount of years that we're looking for the value after. Okay, which is after how many years? 5. Okay, so 1 times 5 up top. Okay, this on this right side can be plugged in the calculator. Okay, there's a couple of different things that you'll want to use on the calculator. Okay, obviously you've got your multiplication here, 1.17. Okay, open parentheses, 1 plus. Okay, this fraction we would need to use what? Alpha y equals. Okay, so this is alpha y equals. Okay, and this exponent, we would use the exponent by using what button? Little arrow button, right? Okay, and so that 1 times 5 is all in the exponent there. Okay.
And I'll put them in parentheses.
Yeah, I'll put them in parentheses. Okay, we can make sure that it's being multiplied. All right, so what do you end up with as your final answer? And what is our value after 5 years?
I got 1.8001.
1.80, right? We're talking about money.
Oh.
Okay, so we're going to round to the 100.
Oh.
Okay, so 5 years ago, this coin was worth
$1.18.
$1.17, right? 5 years later, it's worth $1.80. Okay, so that's how that problem's working. Any questions there?
So it's basically the same thing we did yesterday. Just
That one is basically the same thing we did yesterday. There was nothing different on this problem except throwing in 1. Okay, but when you throw in 1 on the denominator and you're multiplying 1, does that change anything? No. Okay, so this was the exact same thing that we did yesterday. Here's a problem that's really what's new today. Okay, on number 2. Okay, so Gina deposited $1,500 in an account that pays 4% interest compounded quarterly. Okay, this is where the difference is compounded quarterly. What does that mean? How many quarters are in a year? 4, right? So that means that whatever this increases by is going to increase how many times a year? 4. Okay, compounded quarterly means that it's gonna increase 4 times a year. Okay, what will be the balance in 2 years? All right, so here we wanna figure out the amount, okay? But we know the amount will be equal to this 1,500, that was the principal, the initial amount, okay? Times 1, okay, we're increasing, so plus, what's my decimal here for 4%? 0.04. Okay, over what? How many times? Okay, it's happening 4 times a year from quarterly, so it's over 4. Over 4. Okay, then it's raised to the 4, which was n. Okay, and how many years after are we looking for? 2, so 4 times 2. Okay. So now this can get plugged in.
That's 0.04.
Yeah. Okay, what's the number after 8? 5. Okay, 5 rounds up down.
Nah.
Alright, does everybody agree with this number? You see people shaking their heads like this instead of closed eyes, ready to move on to Friday. It's Friday. Y'all look like you know it's Friday. It seems like in here, y'all look like this. Alright, Chris? Any questions on 1 or 2?
No.
The key difference there being compounded quarterly. All right, the Garcias have $12,000 in the savings account. Okay, that would be my what? Initial amount. What's the word we're using today? Same word but different principal. Okay, that's your principal. That's P. Okay, so 12,000 times 1. Okay, the bank pays. Okay, pays would be a good or bad thing. Good, right? You would be adding to your account. Okay, so plus a interest rate of 3.5%. That is what is the decimal? 0.035. Okay, that's all right. So they're paying 3.5% interest on this savings account. Okay, that is compounded monthly. So what is my end value? What is this end value? How many times does that happen in a year? 12, right? There's 12 months in the year, so that end value is 12. Okay? Raised to the 12 power. Okay? And we want to find the balance after how many years? Okay, so 3 represents my T. So 12 times 3, and that's exponent. 13,320. 26 point what? 65, is that right? Yeah. So what y'all got? What's that decimal?
Hold on, let me put it in there.
Tell me that number again. Well, no, 1,000. It's 13,332. Wait. Tell me 1,332. 2.
No, Bob. It's 13326 point.
You put 1,200. We're doing 12,000. I was going to say, my answer wasn't matching yours. I believed in you, but I was like, something's not right. All right, what you got? Somebody.
13326 point.
0.49 should be. What's that number after?
Yeah.
Right, so that rounds down. Okay, that's what we should have. Hey, here's a good point though, and this is not picking on Adrian, I promise. Okay, Adrian was giving me a number that was going to be 1,300, right? What was our initial amount? 12,000. So if we're gaining money, and my answer is 1,300, which is less than 12,000, would that been a red flag to know that you got it wrong? Right, y'all need to pay attention to that as well, okay? If you end up with an answer lower and you're supposed to be increasing, then something might be wrong. Okay, and again, that's not picking on you, but it's just a teaching moment, okay? All right, number 4, okay, determine the amount of interest, okay, earned on a $2,500 investment, okay, if it's invested at 5.5 or 5.25%, okay, annually, okay, it's counted monthly for 4 years. All right, so we've got A, which is equal to my initial or principal, which is 2,500. Okay, it's gaining interest at so 1 plus gaining interest at 0.0525. 0.0525. Okay, and it's compounded monthly. So what does that mean? My N is 12. Okay, N is 12. Okay, raised to the 12 times 4. Okay, because we're trying to determine after 4 years. What do we end up with?
3,082.78.
Okay, 3,082.78. Is that my answer?
No, yes. No.
Okay, I agree that we're working it correctly so far, but is it my final answer?
No.
What does the question ask me?
For 4 months. Oh, no.
What does the question ask me? It asks,
What is earned?
determine the amount of interest earned. Okay, so how would I find that?
Right?
How would I find the amount of interest earned?
You're gonna,
Subtract. Who's that? It's Aiden, right? So you're gonna subtract. Why would you subtract? Because you had the initial amount, right? And that's not interest earned. That initial amount is included in this, right? So that's not what we're necessarily finding. We're trying to figure out what is the amount of interest earned. So you're gonna say 3,082.78 minus 2,500. Okay, somebody subtract that for me.
You get 582.
582.78. Okay, that's the amount of interest that was earned. Okay, because you started with your 2,500. Okay, you earned $582.78 to get to a total amount of $3,000, whatever. Right. So the amount of interest earned was this 500 number. Does that make sense? Okay, this one kind of gave you a hint because interest is bolded, right? Kind of telling you, hey, look for that. Okay. But you got to watch out for that sort of stuff.
So when it says interest,
So if it's asking how much interest is earned, you need to go back and find just the interest amount after you solve it. Okay, which we'll have to do on 5 again. All right, any questions here? No? Okay. All right, number 5. Okay, number 5, determine the amount of interest. Okay, so what does that tell me at the end I'm gonna have to do?
subtract.
Go back and find it, right? So then that could be subtracting, all right? So earned on a $100,000 investment, so you got 100,000. Okay, if it's invested at,
you need one more zero.
huh?
You need one more zero.
It's 100,000, isn't it?
Yes, it is.
It's 100,000.
You can't see.
That's it. That's 100,000?
Yeah.
What? Hold on,
You know what the comment is?
what? I can't see that good.
100,000 has 5 zeros. 1, 2, 3,
Oh,
4,
I can't
5.
see this morning.
1, 2, 3, 4, 5. All right.
Oh.
All right, so we got 100,000. Okay, it's invested at a rate of 5.2%, so 0.52 over. It's compounded quarterly. So what is my N? 4. Okay, there's 4 quarters in a year. Okay, so that means I'm gonna have 4 in the exponent along with what other number?
12.
12, because we're looking after 12 years. So
$25,888.87.
There you go, right? And we gotta figure out the amount of interest earned. Does the amount of interest earned include the initial amount, yes or no? Interest earned, does it include what you already have?
No.
Oh, right. Okay, so we're gonna subtract, y'all think about it this way, okay? Y'all all start a new job, okay, listen to me here, y'all all start a new job on Monday, okay? Everybody in here has $25 in their bank account, okay? At the end of the week, okay, you get your paycheck. It was $10, okay, I'm keeping the number small just on purpose, all right? So you had $25 before you ever started working, okay? You worked the whole week, you got $10. How much do you have in your bank account now? 35. How much did you earn? 10. Did you include the 25 in that? You didn't include the 10 in the amount earned, right? I mean, the 25 in the amount earned, right? You only earned $10 because you already had 25. You earned 10 to get to 35. Okay, so the amount earned is that amount other than your initial amount. Okay, so that's why we're subtracting away the 100,000.
It's gonna be,
85,888.
God damn.
I did too.
I did it on paper.
All right, any questions there? Jalen, you got it? You got a case of the stairs? What you doing? Good. All right, let's move on if everybody's ready. Everybody good? All right, the Fresh and Green Company has a savings plan for employees. If an employee makes an initial deposit of $1,000, the company pays 8% interest compounded quarterly. Okay, if the employee withdraws the money after 5 years, how much is in the account? Okay, so we've got our amount. Okay, we've got our $1,000. Okay, you've got 1 plus, okay, because we're paying 0.08 over compounded what? Quarterly, which is 4. Okay, we'll raise this to the 4th power, and we're evaluating after how many years? 5.
Cinco.
Okay, how much money is in the account after that amount of time? So almost $1,500. Okay, almost $1,500 is in the account. Okay, any questions there? Okay, using the information above, find the interest of the money, okay, if it was withdrawn after 35 years. So what's the only thing I have to change from this formula to after 35 years? The 5 to be 35, right? So this one is A is equal to 1,000 times 1 plus 0.08, same problem, 4 times 4 to the now 35 years. That's the only thing that changed. Okay, if you don't know on the calculator, you can bring back up the whole problem by pressing second enter. Okay, and then you can go in there and just edit that 5 into a 35. Might be a little bit quicker way to type it
It's
in.
15,996.
15,000 what?
996.
.47.
Okay,
Yep.
Cool.
okay,
It's teamwork.
make the dream work.
There it is. All right, any questions on 7? Very good. All right, let's see. All right, number 8, okay,
What was it?
I'm sorry, it was 15,000, 996.47. Alright, Mr. and Miss Boyce bought a house, $96,000 in 1995, and so we got A is equal to 96,000. Okay, real estate has increased at approximately 4% each year, so 1 plus 0.04, okay, over, okay, what? Okay, each year means how many times are we evaluating in a year? If it's each year, how many times are we evaluating? Once. Okay, I see a couple people doing this. Okay, this is only evaluated one time in each year. Okay, but how many years are we evaluating for? From 1995 to 2007. How many years would have passed? Okay, so you got 2007 minus 1995. Okay, somebody said it. What you got? You got 12, right? So this is being multiplied up top with that exponent to the 12th power.
18,000. I think, no, 153,699.1.
0.10. What was that? Actually, the decimal was 0.09 what?
3.
3 rounds.
I thought we were going to the look.
3 rounds which way?
Oh,
Down, right? So that should be 0.09.
I was now looking at 10.
Alright, so y'all know this. This is not really what the question is about. Okay, was this a good investment?
Yeah.
No.
Yeah, right? You made almost double your money, right? Make sense?
Well,
Anytime you can gain money on a house, you're doing good. Okay. Alright, determine the amount of interest earned if $500 is invested at an interest rate of 4.25% compounded quarterly for 12 years. Okay, so we've got A is equal to 500, okay, times 1 plus 0.0425 over quarterly, which is 4.
Out.
Okay,
But it's gonna be, it's still gonna be up there.
it will be up there with the 4 on the exponent. Okay,
Hey, Coach, this my time to fill out, I can see yesterday.
okay. Alright, what we got?
806.
806.
0.11. You're right, that's right.
11, double check mine.
Is it?
I've got 830.41. Is that what somebody else,
Yes,
830?
that's what it is. I keep
800.
on messing up. Oh, no, I got it right. I never mind, I got it right.
Alright, is this what the question asked? What is the question asked?
The answer
As interest earned, okay, so you got 830.41 minus 500. Okay, that gives you 330.41. Okay, that would be your answer, right, Casey? Any questions there?
Thirsty.
Alright, let's see what time we got. We're gonna work one more and then we'll stop. Alright, which I know there's only 2 more, but we're just gonna work this 10. Alright, so looking at 10, okay, determine the final account balance of an investment of $300. Okay, 300, you got 1, it's a rate of 6.75%, so 0.0675 over compounded semi-annually. What does semi-annually mean? How many times would that happen in a year?
3.
Semi-annually.
Semi.
Anybody know?
Nope.
Semi-annually would be 2 times.
Out.
2 times
Out.
a year. Okay, semi-annually would be 2 times. Okay, so then you have 2 in the exponent, and you've also got 20 in the exponent, because we're evaluating after 20 years. Alright, and what is my investment worth now? Somebody tell me.
1,131.70.
questions on that?
I'm often to ask you something, but never mind, I see what you say now.
Alright, so we've got 3 assignments on Khan Academy today. Here in a minute, I'm gonna throw a video on the board about the penny problem that we talked about yesterday. Did anybody pick? What you want? $1 million, what you want? Huh? You want the penny? Okay, Bryce, what you want, penny or $1 million? Penny? Penny? Million? Million? Million?
Man, I'm trying to cash out.
Million?
A meal. On that head.
Million? Alright, we'll see who's right. Hey, give me just a second and I will get these assigned and then we can watch that video while you're working on that kind of cabinet.
Hey, bro, but I'm gonna tell you all that penny really won though. I ain't gonna